Hello, good morning. Today we will be going over the fundamental theorem of calculus. All right, so before I begin, I just want to introduce some notation that I'll be using throughout this video. It'll make everything a lot easier. So to start, I'm just going to say that f of x, it's a lowercase f, is going to be just your normal function, right? That's your original function. That's what we're starting with. As you all know, or should know, to take the derivative, we call it f prime of x, still lowercase. And the additional part that I'll be introducing is that the antiderivative I will be calling big F of x. Okay, so from our starting function, we could take the derivative, make it f prime, or we could take the antiderivative, the reverse, and call it big F of x. Okay, so next up we have the statement of the fundamental theorem of calculus. And that's just going to be right here. It's really got two parts to it. The first part is that the integral from a to b of f of x dx is going to be the antiderivative of b minus the antiderivative of a. Okay? The second part is that part right there, the derivative with respect to x of the integral from a to x of f of t dt is f of x. This part right here is the most important part because it really connects the antiderivative to the derivative, really bridges everything together. However, we could prove that. We could create this statement just using part one. And that's what we're going to be doing today. All right, so a really common way that you'll see these types of questions asked is when you're asked to take the derivative of an integral. This happens fairly frequently, and it's really not that bad. We're going to start off with a pretty simple one. We're just going to say, we're going to look for the derivative of, let's just go from a to x of the square root of x, square root of t dt. All right, really not that bad. So to start off, what I like to do is I like to say, okay, I'm going to ignore whatever's in here. I'm just going to call it just f of x. That's lowercase f of x because that's our original function. All right, so we're taking the derivative of the integral of f of x. Well, we know that the integral of f of x is just going to turn into big F of x. All right, so let's actually evaluate this integral. It's going to end up being big F of x minus big F of a, where a is just a constant. And remember, we're taking the derivative of this whole thing. So it's actually going to be that expression up here is going to be equal to saying, okay, take the derivative of f of x minus the derivative of f of a. All right, so let's actually do this. Well, since big F of x is the antiderivative of f of x, right? It's the antiderivative of the original expression. If I just take the derivative of that, I'm back to where I started. So the derivative of big F of x is just going to be f of x, and we know that that's going to be the square root of x. So that first part is just going to be square root of x, okay, minus the derivative of that. Well, if I just take in take a constant, and plug it into a function, that's going to give me another constant. It's going to give me a number. So the derivative of that is just 0. So that tells us that square root of x is the derivative of this expression. And that's consistent with what we saw over here. That's part 2. Okay, so unfortunately, they're not all going to be that easy. You're going to see some expressions where you have an actual function as the bounds. That's what we're going to do now. Let's look at this example here. They want to find out the derivative with respect to x of 1 to x to the 4th dt. All right, here's what we got. Same as before. We're going to ignore the inside for now, and we're just going to call that f of x because that's just our original function. Okay, now set up this integral. We have big F of x to the 4th minus big F of 1. Okay, that's equal to this right here. And of course, we're taking the derivative of that entire thing with respect to x. All right, so let's start off with big F of x to the 4th. Well, right here we have a function in a function. We have x to the 4th within that antiderivative. So in order to do that, we're actually going to have to use chain rule. Remember, chain rule is used for whenever you have a function of function. Just as a reminder, statement of chain rule is that the derivative of a function within a function, we're going to call that f and g, is just the derivative of the outside times the derivative of the inside. And that's exactly what we're going to do. The derivative of the outside of that big F of x to the fourth is just going to be little f of x to the fourth, right? Because the derivative of big F is your original function. The derivative of an antiderivative takes you right back to where you started. Multiply that by the derivative of the inside. Well, that's just going to be 4x. Okay, cool. So original function multiplied by the derivative of the inside. F of 1, again, f of 1, that's just a constant. So when I take the derivative of that, it goes to 0. So my answer is just f of x to the fourth times 4x. We have to put that back into terms of whatever they give us. So since f of x, we decided was secant x, we just have to plug it back in. So instead of f of x to the fourth, it's going to be secant of x to the fourth times 4x. And right there is your answer. We'll do another one because I know you're just loving this so much. Let's see. We'll do this one. And then we'll get into another special case that I like to address. So we have, they want the derivative of from 2 to 5x. All right, same as before. We're going to take that inside and we're just going to call that f of x. Okay, we're just going to call that inside f of x. That's our original function. Next, we're going to set up the actual integral. We're going to evaluate that integral. So that's going to be big F of 5x minus big F of 2. And of course, we're taking the derivative of all of that with respect to x. Okay, so the derivative of f of 5x, again, that's going to be chain rule because we have a function and a function. That's just going to be big normal f, that's lowercase f, of 5x times 5, because that's the derivative of the inside, minus, well, that's 0, because the derivative of a constant is 0. So we can just ignore that. Okay, so f of 5x, well, since f, we called this, right? That whole thing right there is f. We're just going to plug 5x into there. So that's going to be the square root of 25x squared plus 1 over 5x. Okay, so that right there is our f of 5x. Times that by 5, and that right there is your answer. Okay, so the next part that we're going to be looking at is something that I do a little bit differently than what you may have seen before. So let's just go right into it. You might have seen that the integral from, let's just say, a to b of whatever f of x dx is equal to the negation of the integral from b to a of f of x dx. And this is absolutely true, right? One way you're going this way, the other way you're going that way, so it's going to be the negation of each other. However, I don't think it's that important to really pay attention to because there's kind of a workaround. So what I mean by that is you may have seen something like this where they, same as before, they ask for the derivative and you have like sine of x on the bottom. Sine of x, and we're going to, let's say, 5 of, I don't know, let's go x squared tan x. I'm sorry, that should be in terms of t, not x. Let's go t squared tan t dt. All right, so here we have something a little bit different. Here we have a function on the bottom. On the lower bound, we have sine of x. That's not really going to make a difference. We're just going to do everything the same exact as we did before, no change. All right, so this is what that's going to look like. Again, we're going to call that inside f of x, our original function, and then just evaluate this antiderivative, evaluate this definite integral. We're going to have big F of 5 minus big F of sine x. Or not, yeah, sine x. Okay, and again, we're taking the derivative of this whole thing with respect to x. All right, so you see here that that sine x part, that f of sine x, is being negated anyway because it's on the bottom. Remember, it's always top minus bottom. So you could have rewritten the integral as the negation of the integral from 5 to sine x, just switch the bounds, but you didn't have to. It's an extra step that you just don't have to do. All right, so f of 5 right there, that's going to be a constant, so the derivative of that's going to be 0. So we don't have to worry about that part. And then negative f of sine x, chain rule, function and a function. So it's going to be just negative f of sine x times the derivative of the inside. Well, we know the derivative of sine is just going to be cosine of x, so times cosine of x. We can't leave it like that because we have to get rid of that f. We have to put it back in terms of what they give us. So since f we decided was t squared tan t, it's just going to be negative sine squared x tan of sine x. And then, of course, times cosine x. So clearly it's not like a nice looking answer, but that's just how it is. It's not always going to be so nice. Welcome to calculus. All right, so I think that pretty much wraps it up for this video. Hope you enjoyed. If you did, please smash that like button. Leave something in the comments of what you want me to do for the next video, and good luck with your test.